All right, this is some good music. I'm not caffeinated enough to follow through, but it's great. All right, let's deliver some secure cross-chain communication. I'm Ed. I am the head of engineering at Axelar, and I have a very interesting job because half of my time I basically spend thinking about what people in Web3 actually need to make this industry successful. Before Axelar, I was working at Chainlink. I was responsible for the team, the reliability team, and we were thinking about the reliability and resiliency of the largest Oracle network in the space. And what I did and what I keep doing is generally trying to push Web3 towards something that's useful. And what we do at Axelar is trying to essentially eliminate all those silos and all those blockchains that are disconnected from each other and instead build this one big interconnected network. Because we believe very strongly that this is what Web3 actually needs. It needs to stop being many disconnected things, and it needs to become an actual World Wide Web. I gave a whole talk about it at the ecosystem stage yesterday, so I'm not going to get into it too much. But yeah, I spend a lot of time at work just thinking about what we need as builders, thinking about people in this room, thinking about people who have been at this stage today, what would they need to be successful, what they need to make this work for everyone. And then the rest of my time at work, I spent being a huge fucking nerd and actually building this. So, I have an absolutely incredible team that is probably doing most of the work realistically while I'm here. But anyway, let's start by talking a little bit about how Axelar does what it does. I am going to show some snippets. I am going to show some of our toolkit. And you can follow along, or I will also leave you with some links and manuals and demos at the end of it that you will be able to follow at your own pace if you want. So yeah, to recap, we have hundreds of different chains at this point in 2023. We don't just have L1s and L2s, we also have app chains. We have a lot of new L2s coming up. We have OP Stack. We have completely new L1s with new languages, with new stacks, new principles coming up. Soroban is one of them, and I've tried building on it, and it's absolutely fantastic. But we run the same risk of Soroban becoming just a disconnected part of this industry instead of being part of a whole, which is what we're trying to fix. So what we're trying to do at Axelar is basically let you build anywhere you want and maybe even take advantage of some of the properties that specific chains have, but then also at the same time be where the users are and be able to access the rest of the ecosystem just as easily as you would be able to access any data or contracts available on your own chain. So at this point, Axelar supports 49 chains and counting. Every time I give this demo, I have to check in with the team and ask if it's a new number. It was less when I was preparing the first draft of this. It's 49 now. It's probably going to be a few more the next time I talk about this. So we are going pretty strong. And so far we processed billions in dollars of cross-chain volume just by token transfers alone. Axelar is very simple to use, and I will show you how simple in a minute, because we have several different ways of actually accessing cross-chain, and that takes the shape of both sending and receiving tokens across chains, and also sending and receiving messages. Messages is what we spend a lot of time on because this is what actually enables cross-chain communication. Token transfers across chains are not new, right? Bridges exist, wrapped tokens exist. It's a very saturated field. Lots of bridges, some of them are actually very good. Not going to endorse any specific ones, but I mean, everyone in this room can probably name a few. Messages are a much more interesting problem because they also enable a lot more use cases. And if you've been here right before lunch, we were talking about interchain. We were talking about DAOs. We were talking about governance. And one specific use case that Axelar actually enables, and we announced this a while back, is interchain governance. So if your dApp exists on several different chains, and you have decentralized governance for it, you need the governance vote on your main chain to affect your app's behavior across every chain you support. And one of the apps that actually works with us to make it happen is Uniswap. There is a Uniswap contract on probably a dozen chains at this point, and they all have decentralized governance. And they need those decisions to be replicated on every chain the contract is deployed on. And they need voting to actually work not on every chain independently, but everywhere at once. This is only one specific example of what we can enable. But generally, sending any kind of arbitrary data across chains is the first step towards enabling this world where we don't really care what chain we're on, because it's just as easy to access contracts on a different chain as it is to access a contract on your own. So we will still start with some examples for tokens first, and I will get to messages in a bit. And the first one is deposit addresses. I will show you how it works live right after this, but essentially, Axelar SDK can help you create a deposit address on a source chain that has your destination chain, destination address, and your asset already built in. So as soon as somebody sends tokens to this address that we create, Axelar picks it up and shoots it over to a different chain that you selected. The user doesn't actually have to do anything. It's pre-baked into the address itself. We store it on the network, and we process transfers completely transparently to the end user. So the easiest way to show you how it works is to open kind of our reference bridge called Satellite. Satellite works with deposit addresses. And let's say that I want to transfer a bunch of a USDC from Avalanche to Base. Let's take a random Base address from Basecamp. Let's go. Say we want to send 10 USDC. We want to send 10 USDC to Base to this contract address. And we generate a deposit address for it. It's going to take a little bit. And it's done. So now if you send a USDC to this specific address on Avalanche, it's going to be almost immediately picked up by Axelar and automatically transferred to Base. And you can share this address with your users. You can send funds to this address from a centralized exchange or a decentralized exchange. You don't even need the wallet for this to actually work. It works for you, and all the parameters of the transfer are pre-baked. Very easy to use, very intuitive. Takes less than a minute to set up, as you just saw. Right. The next thing that we have is called interchain tokens. Interchain tokens are a bit more involved, and for now they are EVM specific, but we also want to support non-EVM chains like Soroban as soon as the mainnet release is out. So for now, I'm going to show an EVM-focused demo, and once Soroban is out, we will be able to create interchain tokens on non-EVM chains as well. So Axelar has something called interchain token service, and I'm going to show you the UI, but there is also an SDK available. It's just not as demoable as this. The idea for interchain token is that you essentially deploy the same ERC20 token, the same contract. It doesn't have to be vanilla ERC20. It can be any token contract. You deploy the same contract on many different chains, but you have a shared supply. It works through mint burn, or it can work through mint lock. And essentially, you mint a token on one of the chains, you burn it on another chain. As the token owner, you control the supply, you control the liquidity, you can rebalance it any way you want. You can even make it automatic. You can build it into your own tools, your own apps. And if you want to deploy a new interchain token, you just need to enter your token name. Let's do Meridian token, MTN Meridian. MTN is probably busy. And we are going to mint 10,000 of Meridian tokens in total. We select any chain we want to deploy the token on. So let's deploy it on Polygon, Avalanche, Base, and Linea. And we are going to click a button, sign a transaction. It's going to spend some of my precious girly ETH. And in a few minutes, it's going to be ready across several chains. Since we have to wait for finality on some chains, it's going to take longer than on others. But by the end of the demo, it's going to be available on every single one of them. So we are going to maybe pause here and get back to this a bit later. Essentially, what you'll see when it's done is the same token contract with the same actual token address on every single chain. You will see the shared supply, and you will be able to send some amount of tokens from one chain to another. You will be able to do absolutely everything I just mentioned from this UI. And there is also an SDK, or you can use the interchain token contracts directly to make the same things happen, right? So there we go. Let's get back to a more specific code examples, right? We have one primary method from sending tokens. It takes 4 input parameters, not more than that, literally one call. You send the token to a destination chain, to a specific address on this chain, with an asset symbol and an amount. That's all it takes to send your token across chains. 4 parameters, 1 function call. And now we can go back to sending messages, which is, again, the more exciting part of this. For sending messages, essentially the basic idea is what I mentioned earlier, right? We don't have to move all the tokens to compute to where the dApps are. We can move any part of your dApp, any part of your compute to where the users actually are, to where the liquidity is, to where the tokens are. You can call any contract on any chain through Axelar. And we have 2 main methods that you need to implement. The first one on the source chain is something called call contract. You call any contract on any chain with support with a simple byte string with your payload. On the contract side, you have to implement a method called execute, which basically gets called with a source chain, source address, and the payload that the users are passing on. Very simple. And something else that we also allow to do is pay for gas on the source chain in any token you want. Because the idea of cross-chain contract calls is that you need to pay gas for execution on the destination chain, and you need to pay gas for the execution on the source chain. And we want to make it as seamless as possible. So if you use pay native gas for contract call, we essentially convert your tokens with our gas service to prepay gas on the destination chain for the contract you want to call. We handle all the conversions, we handle gas prices, we handle everything else. And if you ended up paying more to have a bit of a buffer for the call, since it's unpredictable and prices can fluctuate, and if the finality is very long, like gas prices can change since you've actually made the call and until the execution happened. So if you decide to prepay and pay more and guarantee that your transaction actually comes through in terms of in the event of a price fluctuation, we refund you for the remaining amount. So you are going to pay exactly how much gas the transaction actually consumed. And that's it. It's not even a very exciting demo because of honestly how simple it is, right? It's 2 function calls. It's one method you need to implement on the destination chain, and it just works. So to give a quick recap, you can transfer tokens through deposit addresses, through the interchain token service, and the send token method. And you can send messages through either call contract, or we have a sister method called call contract with token, which does exactly what it says. Now let's try going back to the interchain token service, and we'll see that we actually have a new interchain token deployed on several different chains. And we can go to the token page to manage it and balance liquidity. So now we have a 10K initial balance on Ethereum because Girly was our source chain, our main chain. And the same token is getting registered on Polygon, Avalanche, Base, and Linea. As soon as the transactions come through, as soon as the finality passed, you will be able to transfer some of this balance to Polygon or any of the other chains. You can deploy it on more chains that you didn't select at start. Doesn't have to be a fixed list. You can keep adding chains as soon as we keep integrating them. And something else that I want to show that will help kind of maybe understand the whole flow for Axelar is the Axelar Explorer called Axelar Scan. Does it have dark mode? Yes, it does. Amazing. All right. So the way Axelar actually works under the hood is that it's a chain of its own, and we use decentralized consensus, and we use proof of stake to actually validate your cross-chain transactions that come through. Axelar is essentially a decentralized and permissionless network. We don't control your message passing. We cannot modify your messages. We cannot affect anything that the network does. We basically develop this network, but it's 75 different validators that actually run it and are actually responsible for consensus. So if you go to Axelar scan, you will be able to see every single message that passed through the network, every single validator vote, some stats on validator's performance, chain support, and every single transaction with several different steps is also searchable here. If we kind of dig well enough, we will actually be able to see our interchain token being deployed through Axelar. So if we go to a random transaction, like here we have a call contract with token. It originated from BNB and it went to Phantom. And there are several different steps involved, right? You send the initial transaction. You can open it on BSC scan and see that this is essentially a contract call. We paid for gas using the method I outlined before. This is an express transaction, which means that it will get processed optimistically before the full finality has passed. It's confirmed by the Axelar network. So you will be able to even see the polling results and voting results if you want. Takes a while to open. You can get back to it later. And then it's been approved on Phantom, and it's been executed for the final destination contract call. All of that took 19 seconds because it's expressed, because we don't wait for finality. If we waited for full finality, which you can choose to do for added security, it might take several minutes, or on chains with longer finality like Ethereum, it might take many minutes. But that's why we have Express. So if we get back to EVM poll, you can essentially see exactly how the call was validated, how the message was validated, and how all the different validators actually voted on it. We have one no vote. We have 63 yes votes. The no vote probably came from a validator that maybe had availability issues at the time. Maybe the RPC was down. That typically happens, but as you can see, the overwhelming number of validators voted yes. The transaction came through. Again, it's a fully decentralized consensus. Axelar network is based on Tendermint. So originally, we actually started with the Cosmos ecosystem, but we branched out to support EVM, and we are soon going to start supporting non-EVM chains as well. So that's very roughly how it works. And we have some takeaways and some more links for you to check out, as I mentioned, at your own pace, on your own time. We have Axelar docs, obviously, docs.axelar.dev. But we also have more specific examples that you can look at, and some of them actually have like a local dev environment, and even just browser-based, very simple examples that you can follow without firing up Remix or doing something more involved. We also have the Soroban gateway that's in development right now. It's also open source, so if you want to maybe build your own chain and figure out how to integrate Axelar with it, this is kind of based on our reference implementation for gateway contracts. And integrating new chains with Axelar is actually not that difficult, especially with EVM compatibility or IBC compatibility. So you can check out any of that, but we also have a lot of YouTube tutorials. And this extremely cheerful man that you see here is Stephen Fluin, our head of DevRel. And he is clearly very excited about teaching you all how to build with Axelar. I mean, believe me, I'm excited too, extremely. But I was actually born in Siberia and spent like a lot of years there, well into my teenage years. So I kind of look and sound like I'm struggling my way through life. That's why. But Steven actually looks like he's excited to teach you. So check out some of his tutorials. Highly recommend it. I worked with him at Chainlink, and now I keep working with him at Axelar. He's an amazing guy. So, TMI, I know. Anyway, try out the tutorials. You can join our lively community on Discord. Also a very simple link, discord.com/invite/Axelar. And yeah, of course, stay tuned for the Soroban mainnet. We are very excited for Soroban to join this network, to become part of the ecosystem. When it happens, we'll be there. Can't wait to see what you build with it.
Awesome.
Thank you.
Thank you. Thank you so much.